Hello. The general aim I want to do is just give a brief summary of this particular examination, as mentioned down here. I should say this is January 2023. This particular pure mathematics exam. I just want to skim through and just give a few salient statements. I've got the website down here. That'll give you the if you go to there, that'll give you the access to the full worked solutions, and there's also a link to actually download the exam paper itself. So the first question was just basically the trapezium rule. There's not really normally a great deal to say about this. People make mistakes on things like bracketing and so on, but apart from that, normally it's fairly well done. There's a couple of extra bits on the end here where, having worked out the area using the trapezium rule, you need to ask two separate questions down here. Hopefully you can read that. Now this, both of these actually make use of what you've calculated already using the trapezium rule. This one here, it's essentially using sort of for comparison with, say, normal integration, for want of a better phrase. This can split up into two separate integrations. So you've done that already. So you need to subtract the integration for the integral of 2. So I mean that's basically just going back to here. If you the integral of 2 dx will just be a sort of rectangle. 2 times 2. So you basically all you need to do really is subtract 4 from that. And this one here is a bit of a trick question, because all you've done there is you actually just translated it. You translated it by two coordinate units to the right. So basically the area under the curve is exactly the same as before. So the answer to this one is just the same as the original calculation that the original calculation you used with the trapezium rule. Right, excuse all this mess on this one here. What I really want to talk about here is more or less the calculus. The first bit asks you to show the area. Show the surface area. I mean that's fairly straightforward. You've got hold on, can you see the picture? Yeah. So the volume is just 3x squared h, and you're given the volume equals 972. So you can combine those together, and you've got h equals 324 over x squared. So it's fairly straightforward to get a formula for surface area, which you can then insert this formula into to get rid of the h, and there you are. But as I always say on these, it does say show the surface area, so you're actually trying to prove an equation that's given in the exam paper. So you need to show all your steps. There's no fudging here. You've got to show all your steps. Now, having found that expression there, it then says find the derivative with respect to x. Hence find the value of x for which s is stationary, and then find the second derivative and show the value found in part A gives the minimum value of s. So I can say a few things, general remarks here about differentiation. I mean, what the s has here is 6x squared plus 252. So that's the answer to B. Hence, excuse me. Hence find the value of x for which s is stationary. Okay, so what you do is obviously set it equal to 0. I always like to stick in a statement saying that, you know, where necessary, stick in a statement saying that when the first derivative is when you're trying to find the stationary point, the first derivative is 0. Some people just charge in. They find the first derivative, you know, in general would be dy by dx, and then just say, okay, that's equal to 0. But that's not true, is it? You know, dy by dx is the gradient or rate of change, and it's only at a specific special point that dy by dx or whatever equals 0. So I always think, you know, you should actually just put a statement in saying that, rather than just charging in and automatically equating it to 0. That would be the elegant mathematical way of doing it. Right. Hence, so then it goes on to say find the second derivative. The second derivative for this is d2 d x squared equals 12 plus 5184 over x cubed. Right. So, a couple of things I could say about this is, first off, this is sort of the rate of change, if you like. You're looking to see whether that's a positive value or a negative value. What you do not do is you do not set that equal to 0, which some people do. You know, this is you know, it's worth stating that, because some people do set this equal to 0. You know, the first derivative is a gradient, so you're setting that equal to 0 because at the stationary points that gradient does equal 0. But that's not the case here, is it? It's a different scenario, because it's the rate of change of the gradient. As I say, you're just looking to see whether that's positive or negative, and you don't really need to do that specifically, insert specifically. You know, if it's fairly straightforward. So, for example, here that x value you've worked out previously that x value is positive, so you know straight off that expression is positive. But you do need to actually state what you're doing here, you know, or you need to state your understanding. So dx is greater than 0, therefore the minimum. You know, you do need to put this full statement in. If you just state, you know, it's a minimum of whatever, you know, you're going to lose marks. You need to specifically put this in to get your full marks. Right. Just to ram home what I've just said before, I mean, that's your stationary point here. You're setting dy by dx, well, what you're doing here, you're actually doing ds by dx, aren't you? That particular gradient equation, the first derivative will have a gradient. Sorry, the first derivative will be 0 because, you know, the first derivative is a gradient, and that will have a gradient of 0 at that particular point. But when you're going on to the second derivative, you're actually finding the rate of change of this gradient. So the gradient here is is got a quite a high positive value. Down here it's still positive, but it's lower value, and then it slips into a negative gradient. So this gradient is going down. So that therefore, this gradient is decreasing, I should say. So therefore, the second derivative, ds2 over dx squared, would be negative, i.e. less than 0, and that would correspond to a maximum. That's the logic behind it. Obviously, we found the exact opposite. We found that the second derivative is greater than 0, therefore it corresponds to a minimum for the opposite reasons. Right, salient points here are that you don't need to rearrange this binomial, you don't need to rearrange this particular equation by virtue of the fact that the index is an integer. If it was a fraction or a negative integer, you would need to rearrange this so that the first figure inside the bracket would be 1, and the second term would have a magnitude of less than 1. But you don't need to do that here, so you can just go straight in to do the full scale binomial expansion. It then goes on to ask in the second part, given that the binomial expansion, the coefficients of x squared and x3 are the first three terms of an arithmetic expression, arithmetic progression, find using algebra the possible values of k. So I can tell you that the relevant quantities here are 56 to 21 over 2 k squared and 35 over 32 k cubed. Now if you're told that those are in arithmetic progression, what you know is that the difference between them are the same in both cases. By that I mean, if I took the difference between the first two, then that equals the difference between the second and the third. And that's your equation. And you can proceed from there. I mean, it's worth noting that this type of question occurs quite often in when you're dealing with geometric progressions, and people tend to make a bit of a meal of questions like this. But say, for example, A, B, and C were in geometric progression. What you do need to know is that the common ratio is the same in both cases. By that I mean B over A equals C over B. So that would be a common way to progress with questions like this. That's for geometric progressions. All right. So what do we need to say about this? Logarithms, people always make the same mistakes on these type of things. I mean, there's common errors that people don't really understand sometimes. Well, I won't go into the common errors, but there are common errors that apply because people are not aware of the actual rules around logs. But on top of that, people apply different methods to solving an equation like this, which, although they might get the right answer in the end, sometimes they use sort of rather unwieldy methods. So my recommendation is that you just send all the log terms onto one side and then all the numbers onto the other. So for example here I would have log 3 4x over 5x plus 7 equals minus 2. Okay, so I've sent that over to the other side, so it becomes log minus. So you need to know the rule that a log A minus log B equals log A over B. So that's what I've done in one go. And from then on, you just anti-log it. You know, it's just 4x over 5x plus 7 equals 3 to the power of minus 2. And you just go from there. To my mind, that is the most, sort of transparent way of doing this, this type of thing. Now, the second bit. If you can see that correctly, you've got an index here, an R outside the bracket here, but otherwise it's summation. And it's just a matter of, to my mind, of starting off correctly. You got log. Expand the left hand side. You've got log y plus log y squared equals log y all squared. That's just the okay. So you got a cancellation of a single term there. So you need to just know that well, simplifies to this log, and you just need to be aware of the rules here and just don't get confused between the two. So it would help if I get it in terms of log. So that's on the left hand side, that's 2 log a y equals and in general you could set up a this type of thing you'd use to set up a quadratic, but you've only got 2 terms here, so it's a fairly straightforward form of a quadratic where you're just taking out the common terms. So again, I know some people like to substitute and say, okay, let u equal log y and so on, but I wouldn't really necessarily do that unless it is really necessary. I can get by easily with just writing it down like this. And there you are. So again, one of the answers is log a y equals 2. So you just need to be aware of the rules. Y equals a squared, and that's your answer. Right, what I need to stress on this is that you need to show the examiner that you know what you're doing here. Some people, when it says given that x over x minus 3 is a factor of f of x, show that this. Well, some people will steam in and say, okay, well, actually, if you do that, that's probably not too bad. But some people will sort of steam in and say, okay, 3 to the power 3 plus p plus 3 Okay, so some people would just steam in and write down an equation like that. Oh, sorry. I'm trying to ignore the first line. If you just steamed in and wrote a line down like that, that is correct. But you would lose marks there because you're not actually showing the examiner that you know what you're doing. You need to specifically put down the statement that if is a factor, if x times factor, well, that implies that x equals 3 as a root. This is the explanation in full, if you like. Therefore, so you do need to put something down, something like this down originally, just to show that you're using a rule that you know how, you know which rule you're working in. You're not just you know, you need to define the rule you're using before you use it. That's what I'm really saying. If you don't, you'll lose marks. And the same thing is for this second bit. You need to show that, well, I won't write it down again, but you need to show that whenever f of x is divided by x plus p, giving a remainder of 9, then... Okay, so stick your explanation in at the top there, write this down, and then you can write down the equation with p's minus p substituted in. If you don't put the original explanation down about the rule you're using, you will lose marks. So yeah, that's about it. Probably. Do I need to say anything more about this? What it says at the end is, hence find a quadratic expression such that expression like this. I mean, basically, before up to this part D, what you've got is you've got a cubic. F of x equals x cubed plus 9x squared minus x minus 105. So it's saying take that expression and get it into finding a quadratic expression here. Basically to decompose this cubic. Now also you've worked out, well, you're told right at the beginning that you're already given at the beginning one factor, which is x minus 3. So you know one factor. So basically what you're going to do is you're going to take this cubic and divide it through by the one factor, and out will drop the quadratic. It's I won't actually do it. I'll just see if you can check this here. So there's your cubic being long divided by x minus 3. That's the one factor you do know. You divide that into the cubic, and out comes this quadratic expression. Obviously, if you're asked to do so, you could factorize this quadratic as well to get the cubic into 3 factors. That's if it does actually factorize as such. Right, so circles. Again, there's a couple of ways of doing this. The one I would personally recommend is using the completing the square. So we're given the equation at the top there. Completing the square would be x minus 4 squared minus 16 plus y minus 2 squared minus 2 equals 0, which goes down to x plus minus 4 squared plus y minus 2 squared equals 20. So therefore you can work out what the coordinates of the centre are. It's 4 minus, hang on, have I made a mistake there? 4, 4, 4, 4, 4. Yeah. Yeah. So it's the coordinates of the centre minus 4 and 2. And the radius is the square root of this. Okay. So the radius equals square root of 20. The rest is fairly straightforward, probably. The tangent, so you just sort of rejig the tangent and substitute it into the circle equation, and that'll give you the coordinates of the intersection, and then it finds the gradient of the normal. One thing I could possibly say about the normal is that you're given the tangent will be half. That's rejigging what you're giving up at the top there. You're giving the tangent as that, so that's rejigging that. The gradient of normal again. The way I would write it down is gradient of normal equals minus 2. Okay, that's just an error there. I've made a mark with a pen. That's plus a half minus x minus 10. The gradient of the normal is sorry. Oh, hang on. Yeah, sorry. No, that's my mistake, isn't it? The well, yeah. So it's minus half x minus 5. Sorry. So the gradient is plus 2. Yep, sorry. Now, my recommendation for finding the equation of the gradient, finding the equation of the normal, is just to say y equals the coordinates we're using here are minus 6 and 2. So I would find the gradient of the keep saying the gradient. I would find the equation of the normal by just saying y minus 2 equals 2. That's the gradient. X minus 6, and go from there. To me, that's the most transparent and most logical way of going about it. Some people stick down y equals mx plus c and rejig us around there to find out what c is and go from there. So that's not incorrect. I'll give you the right answer. It's just I find it a bit messy. The most logical way is just to do this and then stick those coordinates into here like this and proceed there. So on. Obviously the full equation will drop out complete with the constant. Alright, so I've sort of touched on this already really, the geometric sequences. And this is one specifically on geometric sequences. Here you would set up two separate simultaneous equations. 20, you're given a 20, that equals AR squared, and 12.8, that equals AR to the power 4. And then you just treat them as simultaneous equations, divide one by the other to work out what R is. You can then stick that R back into preferably this one to find out what A is. So you use that to find out what A and R are, which is what you're trying to find in A and B. Now I could say a bit about C. When it says find the smallest possible value of n. So you want so many terms such the sequence sums up you want the terms progressing such that the sum is greater than 156, and you want to know what the smallest term is that's greater than 156. I.e., you got one term that's less than 156, goes on to the next term which is greater than 156, and that's the term you want to find. The sum will be given by this 1 minus Rn. I should have said that R is equal to 0.8, so I can put down something like this, 1 minus R. And what I need is, to do it the correct way, you need to stick it down with an inequality sign. So that's the sum, and I want it greater than 156. So at the end of the day, I'll get something like n is greater than such and such, which will allow me to give you the lowest value of n, which is what I'm required here. Find the smallest value of n. Okay, I won't do this in full, but the point is that this can get a bit messy here. What shall I get down to? Because R is 0.8 and A is 31.25. What I eventually get down to is I think I'll do this on a separate piece of paper. Right, so I get something down something like that, okay, using these values into here. Now, what I do there is 0.n is less than 1 minus 156. 156.25. Because I want to take logarithms on the left hand side, I want to get rid of this minus sign. So I've whichever way you do it, think of it, so multiplying through by -1 or just reversing the signs. But what I have to do in that case is I've had to reverse the sign, this inequality sign. I mean, well, that's the way of looking at it, really, isn't it? If I could say, okay, you've multiplied through by -1, but when you multiply through by a negative number, you need to reverse the signs. So I can then take the log 0.8n is log. I won't do it in full. It's the log of this, okay. Now, what I'm going to do is I'm going to take that down to the front, so that becomes n log 0.8, and then divide through by the log. So it'll be log of that divided through by log 0.8. But I need to reverse the sign again, because log of 0.8 is a negative number. So by dividing through by a negative number, I need to reverse the sign again. So that goes to that, and that will become to 28.85. And the actual answer, therefore, will be n equals 29. n is greater than 28.85. So the lowest value of n is going to be 29. So you can see what I'm trying to state here is that beware of the need to reverse signs, but also you can see what's happening here is that if you didn't do that, you could still get the right answer for the wrong reasons, because you reverse the signs once and then reverse them back again. So if you didn't bother reversing the signs because you didn't know what you're doing, you'd still get the right answer, but you got the wrong method. So it's just something to be aware of. Again, in passing, while I'm on the subject, I need to stress something that occurs quite often. You get an expression like this in the formulation of this series, this expression, I should say, something like that. Now that is definitely not equal to. Okay. Again, this might be quite obvious to people, but I'm going through here, working on common mistakes, trying to report on common mistakes. 0.8 by that does equal 25, but that whole expression there does definitely not equal 25 to the power n. So that's something to be avoided. Right. Important points here. My recommendation is that some people sort of work out a single value for this and then mess around with trying to find the other values. They typically draw diagrams of or sinusoidal diagrams or things with circles on and so on. But to me, this is not necessary. If you've got that expression there, you've got sine. Well, fiddle around with the what you're given, and you get 3x plus 0.1 equals minus 2.5. So I would just say, okay, 0.1 equals, and just stick down all the values. You got minus 411,516, minus 2.73007, 3.553109. Sorry, normally I'd like to. I should have spaced this out a bit better so I could still stick them all on one line. That's the way I would recommend. Just get all the values out right at the beginning, and then just do your straightforward algebra to work out what x is. I mean, if you're unsure as to how many to stick down here, then just stick down as many. If you're unsure whether it's 4 or 5, then stick down 5, and then you can just throw the unnecessary one away at the end. Now, what else do I want to say about this? Yeah, this one here. Again, the golden rule. Golden rule for all equations like this are. Excuse me. If you can get in terms of cosines, then that's what you should do, and that's what you can do in this particular case. You've got 2 sine squared theta over cos theta equals 5 plus cos theta. Always try and get rid of the denominator, so you've got 2 sine squared theta equals 5 cos theta plus cos squared theta. And there you are. You know how to get rid of that. That's 1 minus cos squared theta. and you end up with an equation purely in terms of cosines. So cosines are more advantageous because we're dealing with degrees here. So the general formula will be n360 plus or minus whatever the cosine is. So typically on this one here, you've got two answers: 70.5, 289. So n equals 0 is just the straightforward principal value that you get from your calculator. Then you go through n equals 1, so it's 360 minus the principal value, which will give you that. And then I ignore the 360 plus the principal value, because that will take me out of the range. Yeah. Again, although it might seem obvious to some people, quite a few candidates did not seem to realise that this answer would have two values. Between the 0 and 360, an equation will always have two values. If you're dealing with 2 theta, then you might expect 4 values, and so on and so on. Right, this is a type of thing that commonly leads people astray, so it's worth talking a bit about this. Right, excuse the pencil marks on the right hand side, but hopefully you can work out what's happening here. The first bit's asks you to work out various coordinates values, but at the end, the really important bit is you need to work out the ratio of the area of R1 over the area of R2, which is up here. Now, this is not particularly difficult here, but some people just have problems grasping the concept. I'm only going to do one integration here, and that's to find out the value of R1. Remember, it's the ratio of R2, which one of the round was it? It's the ratio of R1 to R2 that we need to work out. But I'm going to use integration to work out the value of R1, which is just integration between 1 and 0. That's 0, and that's 1, which you would have worked out in the first bits. And the equation is x squared minus 4x plus 5, which is that equation given that's the equation of the curve with that the curve C with the equation y equals x squared minus 4x plus 5. And that will give me, at the end of the day, 3 1/3. Now, sorry, that should be 2. It's obviously x equals 0. Yeah, that's correct. It's x equals 0 or 1, but it's a y value of 2. The point is that I've integrated under this curve to get 3 1/3, but that again is not the value of R1. That's the first important thing to mention. I'll stick that up there. That's 1. No, that's what that integration has given me is the area of this here. So I need to chop off this area, and that's just 2. So the R1 equals 3 1/3 minus 2, which equals 4 over 3. So that's all the hard bits done, really. I integrate in the normal way, but I need to recognise that I need to chop off this bit here to give me R1. How do I work out what R2 is? Well, this whole bit is a triangle. I should have worked out what is f. F is that's x equals 3, and that's, I think, is 5. Yep. So the area of that triangle is just half base times height. So it's 3, half, 3, 3. So that's R1 plus R2 equals half 3. Well, I'll write it down as is good practice, which equals 4.5. So R2 equals 4.5 minus 4.3. Okay, 4.5 is the whole triangle. Chop off this, which is 4 over 3, and that will give me what R2 is. 1906, isn't it? Yeah. And what I was asked to find was the ratio of R1 to R2. So that's it. Okay, the ratio of R1 to R2 is 4 over 3 over 19 over 6, which basically goes down to 8 over 19. So it's just worth having people do make a mess of this because they don't know what range to integrate across, and so on and so on. The only integration is this, to find out under the curve here. I need to chop off that to find R1. Then to find R2, I just use the fact that this is a triangle. And there you are, goes from there. So it's not too bad, but people do make quite a bit of a mess of things like that. Now this one here, this is comparatively straightforward, although it did fox a few people. So it's really a case of just working out the separate consider the case. Oh yeah, so it gives you the case where n equals 3k, and that's not divisible. So really all you need to do is consider the two other cases. You consider and then you consider when n equals, okay, so consider when n equals 3k plus 1, substitute it into the equation just like this, and then just come up with a form that is obviously not divisible by 3. For example, for the first bit, you'll end up with something like, what have I got here? 6k squared plus 5k plus 1 plus 1. Okay, so the left-hand side is 2n plus n plus 1. So substitute that into there. You come up with an expression like this, and that's obviously not, the whole expression is obviously not divisible by 3. So yeah, so it's a bit of a Mickey Mouse question really, but it flummoxed quite a few people, probably because they haven't actually seen anything like this before. And again, something like this, you do typically need to put a conclusion in. So you just need to put something down at the bottom saying, all cases have been considered, therefore 2n squared plus n plus 1 is not divisible by 3. And that's your answer. So anyway, if you're still with me at this stage, thanks very much for listening, and all the best.